All right, we are back. So we're having all kinds of fun talking about energy. So what I've drawn on the board, I want you to kind of get oriented. I've just drawn, it's just a thumbnail kind of thing. We have a space here in the middle. That is the matrix, and that's where we had said we have the Krebs cycle and the preparatory reactions. Those are happening there. And we had said, what did they do? We tore that carbon-containing molecule all the way apart, and we've gotten rid of all of those carbons, and you have exhaled the CO2. And what we have left is the electrons. And for most of the electrons, they're going to be carried by this thing here, this NADH. Now, don't worry about the name of it, and there's another one, FADH2. I don't even know the name of it, so don't worry about the name of it. It's just the initials. It is an electron carrier molecule. That means it's going to be bringing the electron somewhere. So from the matrix, it's going to bring it, we said, to the cristae. And what is the cristae? It's a membrane. And embedded in that membrane are molecules, proteins called cytochromes. There's a bunch of these cytochromes right here. You can see them right there, and then something else that will come into play in a minute. And so what's going to happen is the electron carrier molecule brings the electron here, and then it leaves behind a hydrogen ion. So what is a hydrogen ion? You might remember it's a hydrogen atom which only consists of a proton without an electron. And so the entire atom normally would just be a proton and an electron, but it doesn't have the electron, so it's just the proton. So we have hydrogen ions that are here, and they're left when the electrons are passed to the cytochromes. Okay, I hope you're still with me. Pay attention, people. So what's going to happen is this high energy electron, and we got other friends over here of these. You know, every time an electron is brought, it leaves behind some hydrogen ions, and so these electrons are going to be passed from cytochrome to cytochrome. And as they're being passed from cytochrome to cytochrome, they are going to be pumping hydrogen ions across the membrane. Woohoo! Where are the hydrogen ions going? They're going to the intermembrane space. Now, think about it. We'd said we have two layers of membrane. So the membrane, the cristae and the outer membrane. So the in-between space is the intermembrane space. And so as the electron is pulling and moving these hydrogen ions to the intermembrane space, it's giving up its energy. And eventually, it's just this puny little low-energy electron. And what does it do? It combines with hydrogen ions plus oxygen, and you're going to make water. So if you have electrons, hydrogen ions, and oxygen, you're going to make water. Oxygen, listen to my words, oxygen is the final electron acceptor. It's critical for this process. None of that Krebs cycle and preparatory reactions would happen if we didn't have somewhere for the electrons to go. So oxygen is the final electron acceptor. Okay, so what have we done? We haven't said anything about ATP, have we? What we've done is we've put a whole lot of hydrogen ions on this side of the membrane. Okay, so you look up there and you see we said we have all these NADHs coming in here, bringing their electrons, leaving their hydrogen ions. They all get pumped over there. And then what happens is this thing right here. You know what that thing is? That is an enzyme called ATP synthase. Now, so let's think about that name. It's an enzyme, And we had said ATP, we know what that is. That's that 3-phosphate high energy molecule we've been saying we're going to make. Synthase is to make it. So what is it exactly? It ends up, it's a channel. It's a special kind of a channel though, as these hydrogen ions, where do we have the highest concentration of hydrogen ions? Over there, right? And we had said there's a process called facilitated diffusion, which allows them to come flowing through this enzyme and make ATP. So this is where we're going to make all that ATP. So we've got all those NADHs and all those FADH2s, all those electron carriers. And ultimately, those electrons are going to be concentrating hydrogen ions on that side of the ATP synthase. And then they're all going to come flowing through to this side. And as they flow through, that kinetic energy is going to be used to make ATP. So we're on slides 5 and 6, and that's what we are talking about. So 5 and 6, you see that we have in slide 6, we're seeing what I'm talking about. It's drawn upside down to mine, but anyway, you can see that we have ATP synthase and all these cytochromes, these electron members of the electron transport chain. That's what we call this. And in the end, we're going to make a whole lot of ATP. So if we go back to slide number 7, we've seen this slide, but we were kind of ignoring the ATPs. But if you pay attention to the ATPs on this thing, you can see, okay, in glycolysis, we've got 2 of those ATPs, and we've got some ATPs coming off of the citric acid cycle. But you can follow around all of those NADHs and FADHs too, and you see we make a whole lot of ATP. Okay, I know this has been a fun journey. So that is cellular respiration in a nutshell. It's simple. No, it's not simple, and it's much more complicated than I made it, but I try to break it down so that at least you have an understanding, but without spending a month talking about it. You can spend a month talking about this thing. So don't worry about that part of it. Just understand it at this level, okay? So what do we talk about next? Oh, so before we go from here, we had said you can make energy from sugars. That's what we just talked about, but you can make it from a protein as well, or a triglyceride, that's a fat. And so now if it's triglyceride, remember they're real long chains of carbons. And so if you think about, the glycerol portion of a triglyceride is a 3-carbon piece. So that's like pyruvate. Yeah, I can jump in like pyruvate, and then, preparatory reactions produce a CO2, blah, blah, blah. The other parts can be cut into 2-carbon pieces, acetyls. They can jump into that Krebs cycle as well. If you're talking about a protein, okay, so fats are remember, they are just carbon, hydrogen, oxygen. So they're easy to chop up and feed them into the system. Now, a protein, what does it have? It has an amine. It has a bunch of carbons and hydrogens and oxygens plus nitrogen. You got to get rid of that nitrogen. So we do something called deamination, and that leaves either a 2 or 3 piece of carbon, and it can feed into the system. So you can use sugars, you can use carbohydrates or lipids, or you can use proteins as energy sources with this exact same system. Okay. We'll come back and we're going to talk a little bit about that nitrogen. The nitrogen that we said you got to cut off of those amino acids. Remember, proteins consist of amino acids, which have an amine at one end, nitrogen, and then the rest of it is this carbon and hydrogen and oxygen. So that's next.